Okay, here's a quick video for you guys. Going along with the graphing that we've been doing, sometimes we have inequalities instead of equations. So if I want to graph this linear inequality, notice there's a less than sign here instead of an equal sign. Still going to approach this in the same way that we would graph if it said y equals negative 2x plus 2. Start with our y-intercept, positive 2, and our slope, our m, if it's just negative 2, we can put that over 1, so we're going to go from our y-intercept of 2, down 2 and over 1, down 2 and over 1, down 2 and over 1. This part is totally the same. What's new is what you have to do when you draw the line. Now, because this equation is less than y, but not equal to it, when we draw the line, we're going to use a dashed line to show that it's not equal to that part. Okay, sorry, I had to pause there because the guy came in to try and fix my heater. Like I was saying, which you still remember because you didn't pause. We have to use a dashed line because we're not equal to this line. We're equal to everything less than it. So the other thing that we have to do is gently with our pen or pencil is shade everything that is below, since this is a less than sign, everything that is below that line. And just a gentle squiggle like that or a little more aggressive would be fine. Okay? Let's look at another example. This one says y is greater than or equal to 1/2 x plus 1. Well, plus 1, that's our y-intercept. That's where we're going to start. And 1/2 is our slope. Whoops. Sorry about that. So we're going to go from here up 1, over 2, up 1, over 2, up 1, over 2. Now, in this case, it's equal to this expression, so we're going to use a solid line. Let's see if it's going to let me grab a solid line here. And so we're going to start and do a solid line through, and then we're going to go back and grab our pen, and we're going to gently shade above the line because it's greater than this line. Okay, so we're going to be greater than this line. Next example. Here we have y is less than or equal to 3x subtract 5. So again, start at negative 5 is my y-intercept. The slope is positive 3 over 1, so we're going to go 1, 2, 3, 1. 1, 2, 3, 1. I can keep doing this 1, 2, 3, 1. It's equal to this line and everything less than it, so I'm going to grab a solid line right through here. This is where it starts to get a little tricky. You have to start to be really careful which side is less than the line, okay? Typically, if it's a positive slope, you're going to be underneath it, or if it's a negative slope, you're going to be underneath it if it's less than, or on above it if it's greater than. So in this case, it's less than this positive slope. So this is my area. Part of the reason that we do the shading is that any value in here will make this expression true. So any value of y listed here will be less than what the x value is. So if I pick this point, maybe I'll pick the point positive 3, negative 2. That's part of the solution. 3, negative 2. If I plug in the 3 for the x, so 3 times 3, subtract 5, and negative 2 for the y, is negative 2 less than this? Well, I think so, because if I do 3 times 3 is 9, subtract 5, negative 2 is less than or equal to 4. 9 minus 5 is 4. So that's a way to check as well that you're shading in the correct area. Okay, one more example, I believe. Y is less than negative 1/2 x minus 2. So we start at negative 2 as our y-intercept. The slope is negative 1/2, so it's down 1 over 2, down 1 over 2, down 1 over 2. In this case, it's less than, it's not equal to, so I need to go and get my dashed line. Not equal to that line, just equal to everything less than it. So I go back to my pen. Less than that line is everything underneath here. Okay? Like always, we'll be practicing this in class. See you there.